Our objective in this lesson is to add and subtract rational algebraic expressions with different denominators. But before that, here are the answers in extra problems I gave in our previous lesson. Kindly write your score in the comments section below. Previously, we add and subtract rational algebraic expression having the same denominators. Today's lesson will focus on adding and subtracting rational algebraic expressions having different denominators. And to do that, we have to determine first the LCD. And then we have to rewrite each rational expression an equivalent rational expression with the LCD. And finally, we have to express our answer in simplest form whenever possible. Just remember, when adding or subtracting rational expressions, the denominator should not be equal to 0. Why? Because this will make our given undefined. Let us recall how to determine the least common denominator or LCD. Like what I mentioned earlier, we have to do this and we have to change the rational expression in its equivalent forms having the same denominator. So to find the least common denominator or LCD, first we have to factor the given denominators. Second, we have to take the product of all the unique factors. Each factor should be raised to a power equal to the greatest number of times that factor appears in any one of the factored denominators. To show you, here is an example. Let's determine the LCD of these constants. We have here 3 over 5, 6 over 15, 8 over 30, and 2 over 10. Again, let us recall the steps. First, we have to factor the given denominators. The first denominator is 5. The factors of 5 are 1 and 5. Next denominator is 15. The factors of 15 are 3 and 5. Next denominator is 30. The factors are, we have 3 and 10. And this 10 here has a factor as well, and those are 2 and 5. Last denominator is 10, and again, the factors of 10 are 2 and 5. Second step, take the product of all the unique factors. So our LCD would be the product of all unique factors. So let us determine the unique factors in the lowest level. We have here 2, and then we have 3, and then we have 5. We also have 1, but we don't need to write 1 anymore. Now let us take the product of these unique factors. 2 times 3 times 5 is equal to 30. So the LCD of these denominators is 30. Now let us find the LCD of an algebraic expressions, meaning let's add variables to our given. Our first denominator is x squared plus 4x plus 3. And the first step is to determine the factors. This is a trinomial where a is equal to 1. You may want to check my video on how to determine the factors. The factors of these are quantity x plus 3 times x plus 1. Our second denominator is this, and this is also a trinomial where a is equal to 1. The factors are quantity x plus 3 times quantity x plus 7. Now let us determine our LCD. This is the product of all unique factors. So we have x plus 3 here and x plus 3 here. Let's take 1x plus 3. We also have x plus 1. We do not have it here, so this is also unique. Let's have x plus 1. And of course, we also have x plus 7. X plus 3 occurs twice. We just have to consider it one time for the LCD. Let's have another one. Our first denominator is 5x squared minus 5. Let us determine the factors. We can factor out a GCF, which is 5. So the factors would be 5 times quantity x squared minus 1. Quick check, 5 times x squared is 5x squared. 5 times negative 1 is negative 5. But x squared minus 1 here is difference of two squares, which also has its factors. And the factors of this are quantity x plus 1 times quantity x minus 1. So the complete factored form of 5x squared minus 5 is 5 times quantity x plus 1 times quantity x minus 1. Let's have the second denominator. This is again a trinomial. This is actually a perfect square trinomial. This is a PST. And the factors are quantity x minus 1 is squared, meaning 2 times of quantity x minus 1. Now let us determine our LCD, the product of all unique factors. So we have here 5. X plus 1 is also unique. Let's consider that. And then here I have 1x minus 1, while here I have 2x minus 1. Which one should I consider? 1 or 2? It should be the one with the greater exponent. So let's consider quantity x minus 1 is squared. This will be the LCD of these denominators. Now let us add and subtract. 1 over 10 plus 1 over 15. So let us determine first the factors of 10, and that would be 2 and 5. While 15 is 3 times 5. Our LCD is the product of all unique factors. So we have 2, 3, and 5. And that will be equal to 30. This is the same example I had earlier. So now let us perform the addition. So our LCD is 30. 30 divided by 10 is 3 times 1 is 3. And then 30 divided by 15 is 2 times positive 1 is 2. And 3 plus 2 is equal to 5. So we have 5 over 30. Now, 5 and 30 are both divisible by 5, meaning I can still express this in lowest term, and that would be equal to 1 over 6. So this is our final answer. Let us have another one. Let's determine the LCD, and that would be the product of all unique factors. That would be 3, 7, and 1n. 3 times 7 is 21 times n is 21n. This is our LCD. Let us perform the addition. 21n, our LCD divided by the first denominator, 3n, will give us 7 times m is 7m. 21n divided by 7n will give us 3 times positive 2 is equal to 6. Since there is no way to express this in simpler form, this will be our final answer. Let's have another one. We have here 5 over 2x minus 6 minus 3 over 6 minus 2x. Notice our denominators. We have here 2x minus 6, and this one is 6 minus 2x. So we can do something to make this look the same. So I'll copy first this one, and then in here I will factor out the negative. So by factoring out the negative, this will become negative of quantity 2x minus 6. Quick check. Negative times 2x is negative 2x. Negative times negative 6 is positive 6. Remember our lesson on how we rewrite rational expressions in 3 different ways without changing the actual given. You may want to check on that again. I'll simplify this. Negative negative will be positive. So this time, I have the same denominators. And to add rational expressions having the same denominators, we simply have to add the numerators. 5 plus 3 is equal to 8, while in the denominator, I could factor out 2. 8 divided by 2 is equal to 4. So our final answer would be 4 over x minus 3. Try this. We have negative 2 over p plus 1 plus 4p over p squared minus 1. This is already prime, so I'll just copy this one. And then in here, I could factor out the denominator as quantity p minus 1 times p plus 1. Difference of two squares. Let us determine the LCD. We have p plus 1. I also have p plus 1. So I will consider 1p plus 1 and p minus 1. LCD divided by the first denominator, p plus 1 times p minus 1 divided by p plus 1 will give me p minus 1. Multiplied with negative 2 is negative 2 times quantity p minus 1. And then the LCD divided by the second denominator, which is itself, will give me 1 times 4p is equal to 4p. Let's distribute this. Negative 2 times p is negative 2p. Negative times negative 1 is positive 2. Copy 4p. Let's copy our LCD. Negative 2p plus 4p is 2p. So we have 2p plus 2. Then in here, 2p and 2, I could factor out 2. 2p divided by 2 is p. 2 divided by 2 is 1. Copy the LCD. You will notice that we have a common factor, and that would be p plus 1. Let us cancel them. Our final answer is 2 over p minus 1. Let us do extra challenge. We have here x over x squared minus x minus 2 minus 1 over x squared plus 5x minus 14 minus 2 over x squared plus 8x plus 7. This is a trinomial where a is equal to 1 and the factors are quantity x minus 2 times quantity x plus 1. This is also a trinomial where a is equal to 1 and the factors are quantity x plus 7 times quantity x minus 2. Another trinomial where a is equal to 1 and the factors are quantity x plus 7 times quantity x plus 1. Let us determine our LCD. Let's take all unique factors in our denominator. So let's have 1 x minus 2, 1 x plus 1, 1 x plus 7. X minus 2, I already have it here. X plus 7, I already have it here. X plus 1, I already have it here. So these are all our unique factors. The LCD divided by the first denominator, the common factors are x minus 2 and x plus 1, meaning we are left with x plus 7. Times x would give us x times x plus 7. The LCD divided by the second denominator. What are the common factors? We have x plus 7 and x minus 2, meaning we are left with x plus 1 multiplied with negative 1. So that would be negative quantity x plus 1. For the third term, let's copy first the sign here, which is negative. The LCD divided by the third denominator. What are the common factors? We have x plus 7 and x plus 1. So we are left with x minus 2. Multiplied with 2 will give us 2 times quantity x minus 2. Now let us distribute. X times x is x squared. X times 7 is 7x. Negative times 1x is negative x. Negative times positive 1 is negative 1. Negative 2 times x is negative 2x. Negative times negative 2 is positive 4. Let's copy our LCD. Let us simplify this. No other terms include an exponent of 2, so let us copy x squared. 7x minus x is 6x. Minus 2x is positive 4x. Negative 1 plus 4 is positive 3. Let's copy again our LCD. Now, this is a trinomial where a is equal to 1 and it is factorable. The factors are quantity x plus 3 times quantity x plus 1. Let us take a look if we have common factors, and yes, we do. X plus 1, let's cancel them. So our final answer would be x plus 3 all over quantity x minus 2 times quantity x plus 7. For the summary, here are the things that we learned in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. So perform the indicated operation. We have here 1 over x squared minus 1 minus 2 over quantity x plus 1 squared. This is difference of two squares and the factors are quantity x minus 1 times quantity x plus 1. While in here we cannot do anything, so I simply copy it. Let's look for our LCD unique factors. We have x minus 1. And then this is x plus 1 raised to the first power, while this one is raised to the second power. So we have to choose the one with a higher exponent. So we have quantity x plus 1 is squared. LCD divided by the first denominator. What are the common factors? We have x minus 1 and 1x plus 1. So meaning we still have one more x plus 1. Times 1 is still x plus 1. Let us copy this one minus. Next, LCD divided by the second denominator. The common factor is quantity x plus 1 squared. So we are left with quantity x minus 1. Multiplied by 2 will give us 2 times the quantity x minus 1. Let us remove the parenthesis of this, x plus 1. Negative 2 times x is negative 2x. Negative times negative 1 is positive 2. Copy the LCD. X minus 2x is negative x. 1 plus 2 is positive 3. And let's copy our LCD. There are no common factors that we can cancel out, so this will be our final answer. Gets? Here are some problems for you to work on to master this lesson. Check out for my new lesson where I reveal the answers. Our next lesson is solving problems involving rational algebraic expressions.